Okay, well, thank you everyone for calling in tonight on this beautiful evening. My name is Adrian Liu. I am a professor at McGill in the Department of Physics and the McGill Space Institute. And tonight, this is our Comet NEOWISE event. And so just a few housekeeping procedures for now. What we're going to do is we're going to start with a short talk by PhD student Taylor Bell. Now, during the talk, you can ask questions, and the way you can do that is if you're on Zoom, you can either click on the Q&A box and ask a question there, or you can type it into the chat box. And either way, I will see the questions and I will pose them to Taylor at an appropriate moment, most likely at the end of his talk. At the same time, if you are watching us on the live stream on Facebook, and in fact, most of you are, simply comment on the video. And that way, we'll be monitoring the comments, and same thing, I will pose the questions to Taylor when he is done with his talk. And so this event today is brought to you by Physics Matters and Astro McGill, which are the outreach arms of the Department of Physics and the McGill Space Institute, respectively. If you are interested in future events, you can follow us on Twitter, you can follow us on Facebook, or you can send an email to outreach@physics.mcgill.ca, and we'll add you to our mailing list. So without further ado, Taylor, please take it away.
Hi, everyone. So yeah, we're talking about Comet NEOWISE. Today, I'll talk more generally about comets to start, and then we'll get into Comet NEOWISE. But first, a little bit of note of introduction as to who I am. My name is Taylor Bell. I am a PhD student at the McGill Space Institute at McGill University. And my research focuses on characterizing the atmospheres of exoplanets. And so through that, I've learned some about comets, and I'll share with you some of the knowledge that I've gained so far. So first, I want to start it off with a definition to cover what even a comet is and where these dirty snowballs, as they're sometimes called, come from. So comets, asteroids, and meteors and shooting stars are all understandably confused with each other. So first, some quick definitions. An asteroid is a chunk of rock debris left over from the formation of the solar system that can vary from dense rock and metal to less dense icy material. Asteroids can be found throughout the entire solar system, but are mostly found in the asteroid belt between Mars and Jupiter. Then meteors are what happens when the asteroid enters into the atmosphere of a planet and burns up in the atmosphere due to the extreme friction with the air. A meteorite is what we call a meteor when it impacts the surface of that planet. And I forgot to mention a meteor and a shooting star are the same. And then we have comets, which are actually quite similar to asteroids in many ways, but there are some key differences that I'll go into now. So comets typically come from the distant edges of the solar system where ice was abundant when the solar system was being formed. As a result, these objects tend to be more rich in ice, and they tend to be less dense than their asteroid friends. Comets are also necessarily on really highly eccentric orbits around the sun, which bring them from those distant edges of the solar system in towards the sun. And then if the comet, when near the sun, the comet heats up and some of the ice in the comet is released as gas and dust and creates a coma around the nucleus, which is the solid body, and then trails behind as both a ionized gas tail and a dust tail. If the comet survives its pass near the sun, the coma and tail will then diminish. Meanwhile, asteroids don't have any similar atmosphere or anything like that. The gas tail is pointed almost exactly away from the sun. It is shaped by the interactions with the solar wind of particles cast off by the sun. And the gas either appears blue if rich in carbon monoxide gas or green if rich in carbon. Meanwhile, the dust tail is mostly white and it's pushed by the photons from the sun. And it more closely follows the comet's path. And I just remembered that I was going to turn captions on. So there we go. That should work now too. Moving on, we have some details about the composition of comets. As I've mentioned, comets are very loosely packed objects with a typical density of only half that of ice. Knowing that comets also contain significant amounts of rock means that much of the comet is actually empty space. To learn more about the composition of comets, the European Space Agency launched the Rosetta mission to study Comet 67P, and the mission had with it Philae lander. The Philae lander was going to land on the comet while the main Rosetta satellite orbited. And the Philae lander was going to launch harpoons to anchor it to the comet due to the low gravity of the comet. But surprisingly, Philae's harpoons were unable to penetrate the comet, and the lander actually bounced off of the comet's surface. After bouncing twice, Philae achieved the first ever landing on a comet nucleus. The results of the Rosetta mission and the Philae lander suggested that comets are actually more like deep fried ice cream with a layer of outer rock, dust, and ice, while the interior ice and rock is colder and less dense, which I've kind of depicted here. There's also bits of ice that near the surface are cracks that expose ice, and it's through these that the comet has jets of gas and dust that fuel the coma and the tail of the comet. And then finally, you'll notice the strange shape of the comet I've depicted here and the actual image of the comet here. This is actually quite common for comets and asteroids and suggests that there were two separate objects that gently collided with each other and ended up getting stuck to each other. Moving on to the orbit of comets. As I mentioned earlier, comets typically come from the outer edges of the solar system. There's two general classes of comets, depending on where they come from. There's those from the Kuiper belt, which is just beyond the orbit of Neptune, which are called short period comets, and they have orbital periods of less than 200 years. And then there's the long period comets that come from the much more distant Oort cloud, and they have periods longer than 200 years. Since these two comets start at very different distances from the sun, but both come very close to the sun, their orbits have to look very different from each other. And the parameter we use to describe the shape of the orbit is the eccentricity. It ranges from 0 when you have a circular orbit and increasingly elongated ellipses as your eccentricity approaches 1. Anything with an eccentricity of 1 or more will actually leave the solar system entirely. So I'm now going to talk about some famous comets that you've likely heard about, and then we'll move on to the comet currently gracing our skies, Comet NEOWISE. First up, we have the extremely famous Halley's Comet. Halley's Comet is known to have been observed as far back as 240 BCE, when it was observed by Chinese astronomers. However, it's possible that it could have been the comet that the Greeks observed back in 467 BCE. Halley's Comet most recently passed in 1986, where it was barely observable from Earth, but it was previously very easily observable in 1910, and it will be visible again in 2061. During the comet's 1910 passage, an astronomer discovered the presence of a toxic gas called cyanogen in the comet's tail, which led them to claim that when the Earth passed through the gas left by the comet, the gas would, quote, impregnate the atmosphere and possibly snuff out all life on the planet. as we can see, his wildly inaccurate prediction was inaccurate, and it led to panic buying of gas masks, anti-comet pills, and anti-comet umbrellas by the public. In reality, as other astronomers quickly pointed out, the cyanogen gas was so diffuse that nothing could happen to the Earth's tail, to the Earth as it passed through the gas left behind the comet. The air we breathe is 1,000,000 billion times more dense than the gas of comets, and a tiny bit of cyanogen in that tiny bit of gas just can't have any impact on the Earth. Next, we have the Comet Shoemaker-Levy 9, which was discovered in 1993 by Carolyn Shoemaker, her husband Gene, and David Levy, which was discovered at the Palomar Observatory in California. Carolyn has herself discovered more than 800 asteroids and 32 comets in her life. Comet Shoemaker-Levy was particularly interesting because it was orbiting around Jupiter when it was discovered, not the Sun. Apparently, the comet had previously passed close to Jupiter and had started orbiting it instead. Comet Shoemaker-Levy was later observed as a series of fragments, all about 2 kilometers in size, which eventually collided with Jupiter's southern hemisphere in July of 1994. And the fragments had a speed of nearly 216,000 kilometers per hour. And the prominent scars that I've shown in this image here were more visible than the Great Red Spot and persisted for many months. Another very famous comet is Comet Hale-Bopp, discovered independently by 2 observers on July 23rd, 1995, Alan Hale and Thomas Bopp. The comet was easily visible from the ground for a long period of time and was widely covered by the media, which meant that Hale-Bopp was probably the most observed comet in history. For example, a full 69% of Americans had seen Hale-Bopp by April 9th, 1997. And now we'll turn our attention to the comet currently passing near the Earth, Comet NEOWISE. Comet NEOWISE was first discovered earlier this year on March 27th by the NASA Space Telescope NEOWISE. The comet is particularly exciting because that's the brightest comet in the Northern Hemisphere since Comet Hale-Bopp in 1997. While the comet isn't as easily observable as Hale-Bopp, it can still be seen from within the city with a pair of binoculars, cameras, or even smartphones. Here's an image from Jean Mance Park where the comet is clearly visible, and that's just taken with a smartphone propped up against a fence to keep it still. And then while it's challenging to see the comet with the naked eye due to the strong light pollution from streetlights, it is possible. And I'll go into some more detail on that later on. So the NEOWISE mission is the one that discovered it. And it was made possible by repurposing the retired WISE infrared space telescope that was launched back in 2009. The mission is looking for near-Earth objects called NEOs, hence the name NEOWISE, which are of particular interest since some of these could potentially end up impacting the Earth. The mission so far has made many discoveries, including 28 comets, 262 near-Earth asteroids, and 47 potentially hazardous asteroids, which are objects that could potentially impact the Earth in the future, although 98% of potentially hazardous asteroids known pose no risk over the next 100 years. But fear not, at its closest approach just yesterday, Comet NEOWISE was still an enormous 103 million kilometers away from the Earth. The comet is now moving further from the Earth and the Sun and won't return to the inner solar system until around the year 8786. So now's the time to see the comet if you want to see it at all. Comet NEOWISE was even observed from the International Space Station. I'll show you the video of that now. So we start with this video clip of the International Space Station orbiting over the Earth. We see the Pleiades star cluster, sometimes mistaken for the Little Dipper, and we see the comet NEOWISE rising above the Earth, shortly followed by the sun. So you want to know, how can you see the comet yourself? There's no need to go to space or even outside of the city to see the comet. I myself have seen it twice from Parc Jean-Mance. If you can get outside of the city, though, it'll help you because you won't have to deal with the city's light pollution. You want to wait until about 9:30 p.m. and find a place where the northwestern horizon is clear of streetlights, trees, and buildings. And that's Montreal Northwest, which is, that's magnetic northwest, which is about Montreal North. And you'll need a clear night without clouds. And tonight is actually looking very good in Montreal, so tonight might be your chance to see the comet. The comet is actually moving quite fast from night to night, as it's currently at its closest point to Earth. So to find it, as of tonight, you want to look roughly halfway between the handle of the Big Dipper, which is shown here, halfway between the handle and the horizon. Right here is where the comet is. If you're looking for different tools to help you find the comet, I personally highly recommend Starwalk 2. It's a beautiful free app that has some paid options in it. Notably, unfortunately, the positions of comets are unavailable unless you pay for them. And then another great option is the Stellarium online web tool and app. And also, Stellarium also told me that the International Space Station is actually going to be flying over Montreal tonight at 10:10. So it'll be perfect timing if you're out there observing the comet. It'll fly over top of you. You'll see it as a very bright, rapidly moving dot in the sky. It'll take 3-4 minutes to cross the entire sky. So it's moving at a good pace. And it'll actually cross twice. It'll cross again at about 11:30. And so, yeah, with that, I'll stop my presentation there, and I'm happy to take any questions if there are any.
Thank you, Taylor, for a really nice presentation. And we do have some questions, and so I will pose them to you, some of which you answered already. As you were talking about comets, we got a lot of questions about, can we see it tonight and can we see it in Montreal? So you preempted that. One question is about that slide when you talked about comet tails. You had mentioned something about the tails and photons from the sun. What are photons?
Yeah, sure. So photons are just particles of light. It's just another word for a piece of light. And through Einstein's special relativity, we know that anything that has energy has mass. And so photons, pieces of light themselves, when they hit pieces of dust, they actually push the dust a little bit. And so that's how you move the dust tail a little bit. And that's why we have a clear solar system to begin with. And we don't have a big cloud of dust around the whole solar system. The sun's photons, light, pushes out the dust outside of the solar system.
Okay. Another question. So should I think, and I'm going to paraphrase this one a little bit, should I think about the comet's tail like a plane's contrail that will eventually fade away?
Yeah, that's a pretty good way of thinking of it. So it's stuff being expelled from the comet, and it's something that will dissipate over time. And it's like a contrail. It's being pushed by, the contrail is being pushed by wind. For the dust tail, is being pushed by photons, and the gas trail is being pushed by solar wind. And then beyond that, when the comet gets beyond the nearest parts of its orbit, it'll start cooling down, and the tail will just disappear entirely.
Great. All right, more questions flooding in. Will the comet be visible from South America?
Oh, so it's currently in the Big Dipper, like I showed. So anywhere on Earth that can see the Big Dipper should be able to observe it. So the northern tips of South America should be able to observe it. I'm not actually sure just how far south you can go and see the comet, though. But the other problem is the further south you go, the lower on the horizon it's going to be at the time that you can see it. So in Montreal right now, it's about 2/5 heights above the horizon. And as you go south, it gets lower and lower. And so you'll start getting into trees, and eventually it'll just be below the horizon.
Mm-hmm. Great. Okay. Do we know for sure that it won't, after it slingshots around the sun, just be kicked out and never return?
Yeah, so that's what I didn't mention this at all, but I have in the slide here. We have measured the eccentricity of the orbit, and so because this eccentricity is less than 1, it is still bound to the Earth, to the sun. Should something happen far out in its orbit that it gets a little bit more of a kick out of the solar system, it could leave. But no, as of right now, it's coming back in 6,700 years. Yeah.
Great. And for its current passing, how many more days do you think we'll be able to see it? You know, the comet will be visible until when?
Yeah, so it's a tough question. So there's kind of two things that are at play right now. Initially, the comet was towards the sun, of the interior to the Earth's orbit, closer to the sun. And it was also more in the direction of the sun. And so that made it very hard to observe because you could only really see the comet when it was daylight. And then now that it's moving further away, we're starting to see it more in the evening. So that's one thing that's making it easier to see. The other thing that was making it easier to see until yesterday is that it was moving closer to the Earth. As of yesterday, it's getting further out behind us now. So it'll be getting fainter. And then worse than that, it's also moving away from the sun, which is its source of light. We don't see light emitted by the comet. We see light reflected by the comet. And so it's just going to keep getting fainter and fainter. And even worse than that, it's also going to stop emitting all of the gas as it cools down. So I don't have a firm answer. I would feel okay about saying we have a few more days left. I don't expect in a month there's any chance that we'll be able to see it.
Okay. Another question is that people have noted that with a lot of the nice photos that have been taken of them, they're interested, and I'm folding a bunch of questions into one here. What determines the different colors that one sees, like with, say, comet tails?
Yeah, so I mentioned that earlier at the talk. I know people come in and out. So this is a perfect image of that Comet NEOWISE, imaged from Germany earlier this year. So we see this big, fluffy white tail here, which is made of mostly dust blown off from the comet. And it's white just because it's fairly small particles. And then we have this blue streak here, which is ionized gas that's blown off of it. So it's gas that has electrons ripped off of the molecules. And then that has this bluish color. It's blue when it's carbon monoxide rich, when there's gas with carbon monoxide in it. And then it has a greenish color in some comets when it's more just carbon rich rather than carbon monoxide.
Okay, and that neatly answers another question we got, which is the difference between a comet's atmosphere and a planet's atmosphere. And, you know, obviously we're not filled with carbon monoxide and carbon for us. Great.
Yeah, actually, an interesting point along that line, though, is that much of our water on Earth was probably, well, at least some of it was probably delivered by comets. There's not that much in the region where the Earth was forming. And so it's believed that at least some of the Earth's water could have come from comets and asteroids after it had formed. So the components of comets do make up a fraction of the Earth and our atmosphere and our water. But yeah, we're not suffocating from carbon monoxide and all these other poisonous gases.
Great. I will ask you one more question. We've got another set of questions in the on Facebook, and what I'm going to ask you to do is when we go on to the trivia section of this event, maybe you could also log onto Facebook and just answer some of the later questions there.
Sure.
But one question is, let's end with this one. You know, you mentioned a whole bunch of comets, you know, NEOWISE, Halley's Comet and all that. Which one fascinates you the most? Which is your favorite?
I mean, Comet NEOWISE is the one that's in vogue at the moment, so it's a lot of fun because it's here. It's the first comet I've ever seen with my own eyes. I previously took images of Comet ISON back in 2014, I think it was, ish. And so I had images on a camera, on a monitor, but actually seeing with my naked eye, with binoculars, with telescope, Comet NEOWISE is just super fun.
Wonderful. Okay, thank you very much, Taylor. Great talk and great Q&A session. As I mentioned, Taylor will be logging on to Facebook and